Good morning, everyone. Welcome to our ExxonMobil Oil Spill Response Knowledge Transfer webinar, and this is our webinar 18. This is also our second talk on the Oil in the C4 series, and we have Dr. John Farrington with us today. I think many of you have known John. John Farrington is Dean Emeritus at the Woods Hole Oceanographic institution. He arrived at the institution as a postdoc in the summer of 1971 in the laboratory for Dr. Max Glammer, an organic geochemistry, who was at that time conducting research on the fate of number 2 fuel oil from the Barge, Florida spill for September 1969 in the West Falmouth oil spill. That's probably John involved in the oil spill business. So John will provide more of his background in his presentation. So I'm not going to go to the details of John's bio. But before I give the floor to John, I need to quickly go through the some format of our webinar. So for the timing, our webinar normally will be held every Tuesday of the month between 10 to 11:15 U.S. Houston time. But occasionally, like this webinar, to avoid holidays, so we moved the webinar. So we moved the webinar today, and John will give an hour, around an hour talk, and then we will leave around 15 minutes for the questions. So we'll go through all the questions online. And attendees can only type your questions through Q&A button, and then we'll go through the questions at the end of John's talk. And for your information, we are going to record the webinar series, both audio and video. I have already put the link in the meeting invite. We already put most of our past webinars in that link. And we'll keep uploading the recordings as it's ready. So now I will give the floor to John. It's your turn, John.
Thank you very much, Lynn, and thank you for those of you who are attending live and those of you who may be viewing this as a recording. The title here is shown on the screen. I'm going to give some key messages from Chapter 2 and Chapter 3 of the recent Oil in the C4 report from the National Academies. I need to acknowledge that I am here courtesy of the people in the Internet Technology Group at Woods Hole Oceanographic Institution as an emeritus scientist, an emeritus dean. They support my computer system, and so I do want to give them an acknowledgement. It's a great team. I've been very fortunate to be at the Oceanographic Institution for the bulk of my career. We at the Woods Hole Oceanographic Institution now traditionally start our presentations with this particular slide. We collectively acknowledge that Woods Hole Oceanographic Institution is located on the unceded, ancestral, and contemporary land of the Wampanoag people. We acknowledge the Mashpee, Quina, Herring Pond, and Asana Wampanoag tribes as the original stewards and protectors of this land and surrounding waters. We recognize the perpetuated detrimental effects that systemic governmental oppressions have had on the indigenous communities as a result of colonization. By offering this land acknowledgement, we accept our responsibility to understand this history, invest in reconciliation, and build accountable partnerships with these communities. Thank you for letting me bring this to your attention. For those who are interested in more of my background, my CV can be found at Woods Hole Oceanographic Institution's website. In the upper right-hand corner of that website, you click on directory and then search for Farrington. I'm not going to go through all of the various activities I've been involved with. My professional interests are the biogeochemistry of biosynthesized organic compounds and human mobilized and synthesized organic compounds in the marine environment. I've had a long-standing interest in graduate and undergraduate education in marine sciences and environmental sciences, and have participated in both teaching, advising, and in leadership roles. I'm interested in undergraduate and graduate education in general. I have an interest and have been active at times at the Science Policy Interface. I have a strong interest in science technology education for the general public and communicating science and technology. And lastly, I have been active and involved in the interfaces between religion, science, and the environment. Indications of my approach to professional matters. Here are two of my favorite quotations. The first from John Adams: "Let us dare to read, think, speak, and write." The second, and the one that I have now attached to my emails that go out, is "Chance favors the prepared mind" by Louis Pasteur. And I've had experiences during my career when unexpected findings have occurred in our analyses. And as a result, we've all of a sudden said, wait a minute. And because we have read widely, that is myself and my colleagues in my laboratory group, my co-workers, we were able to take advantage of this unexpected finding. In terms of experience with oil spills, it's very limited in comparison with others. The Barge, Florida, West Falmouth oil spill, which we've mentioned already, is a #2 fuel oil spill. And I arrived about 2 to 3 years after the spill and studied it on and off, the fates aspects, for about 20 years. Less famous, but equally important, about 4 years after the West Falmouth oil spill, or the Barge, Florida spill, the barge Bouchard went aground and spilled oil in North Falmouth. It was almost like a replicate spill, except it was in October of 1974, and we studied that. I participated in 2 cruises to the MV Argo Merchant spill off of George's Bank. That was a #6 fuel oil. I have to say that our attempt at a cruise in mid-December did not go very well. There was a huge gale that came in with snow and ice. The top of the ship got iced up, and we, for safety reasons, we had to leave and come back in. That one, though, was when I had the first interaction, and I believe it is the first time that NOAA's oil spill response group wasn't called it at that time, not that name, but they responded along with the Coast Guard to that spill. And I was very impressed with how these people got out into the rough weather, terrible winter conditions, and did their very best to give guidance to the people in charge of trying to respond to the spill. Fortunately, unusual circulation conditions at the time carried that spill offshore. And by the time we got back out in January, it was very difficult to find any oil except in very few places. If the circulation had been different, it would have been very much of a problem for Nantucket and the outer Cape Cod. I went to the Ixtoc well blowout on a cruise, a NOAA cruise to the Bay of Campeche. It was a cruise of several weeks to the well site, and then along the coast of western Gulf of Mexico up through Texas, taking various samples. And I did view aspects of the Evo spill in Prince William Sound, Alaska. They were field visits only. I wasn't involved in research. At that time, I was the chair of a National Academies committee that was addressing issues about the adequacy of information, environmental information to support lease sales off the coast of California and Florida in particular. And that committee reported to a cabinet level task force of President George H.W. Bush. So I did get to see what went on in some places in Prince William Sound, but of course, nothing compared to what many other researchers and responders witnessed and participated in that particular area. As was pointed out by Lynn, this is the second in a series of presentations about the National Academy report, Oil in the Sea 4. The presentation by Dr. Kersey Tika, member of the National Academy of Engineering and chair of our committee, provided an overview of the entire report. And this presentation will offer a few thoughts about inputs in Chapter 5, but begin with an introduction and underpinning information from Chapter 2. And I'm very grateful to members of the committee who allowed me to make these presentations on their behalf. Speaking of the committee, the membership is indicated here. This was a wonderful committee, a great team effort led by Kersey Tika and our vice chair, Ed Levine. Steve Bouchang was with us through August 2021 and contributed substantially, but then he became an employee of the US federal government and therefore was no longer eligible to be on this particular committee because of the agency he was working with. I'd like to give special acknowledgements to the Ocean Studies Board staff, in particular Kelly Osgood, the study director, people indicated here, and at the bottom is an acknowledgement, several others behind the scenes. We all know that these are important people who managed to help the whole team work. We had several invited presenters to a series of open meetings, and I've listed these in alphabetical order in terms of what they represented: government agencies, indigenous peoples, industry, non-governmental organizations, and then several people from universities and colleges, if you will, academia. Now, the information that follows in this webinar is drawn mainly from the NASEM Oil in the Sea report. I will be interjecting personal comments informed by my experience with all four National Academies Oil in the Sea reports, 1975 to present. Please note that the personal comments are my own and not official views of the National Academies or of the National Academies Oil in the Sea 4 Committee, nor of Woods Hole Oceanographic Institution. As Kersey Tika noted in her introduction, and I think by now most of the people involved in this webinar know that there have been four in the series of reports. The first was in 1975 called Petroleum in the Marine Environment, and I was fortunate as an early career scientist to participate in the workshop in 1973 and the follow-on writing of the report, not as a member of the guidance committee, but as one of the people who contributed material for the committee to review and incorporate in the report. In the 1985 report, I had the honor of being a member of the steering committee. For the 2003 report, I was one of the reviewers of the report. And for the 2022 report, I was a member of the committee that wrote the report. Now, here's a personal observation. I think this is probably obvious to all of us, but I think it's important that we keep this in mind. Advances in underlying fundamental sciences and engineering technology have contributed significantly to understanding inputs, fates, and effects of oil in the sea. The second point, expanding rapidly from the late 1960s onwards, experiences of a range of oil spill response scientists and engineers, policy and management people from government, industry, and consulting companies have contributed significantly to understanding inputs, fate, effects of oil in the marine environment, oil spill response, and that they have involved informed policy and management decisions. In addition, indigenous peoples and people from the nonprofit sector have interacted productively with the preceding groups. And then many scientists, engineers, policy and management specialists from the academic sector have interacted productively with the preceding groups. No doubt there have been debates and disagreements. I've personally participated in those. However, I contend that these have contributed to and refined advances in understanding and response to oil inputs, fates, and effects. Now, returning to report structure. These are just brief description titles of Chapter 2, Chapter 3, and 4, Chapter 5, and Chapter 6. There was an introduction, which is Chapter 1, and there's a final chapter, Chapter 7, which has a summation and the significant conclusions and recommendations. Chapter 2 deals with what is oil. Chapter 3, where does the oil come from? What can be done is the response aspects, and some aspects of the response are at the end of Chapter 3, but mostly in Chapter 4. Where does the oil go? Fates. And what harm could the oil do? Effects, including effects on humans and human communities. So let's do Chapter 2 and Chapter 3, which is my charge here. And I will say that I want to give credit to several of my colleagues on the committee who contributed significantly to Chapters 2 and 3. And particularly in the inputs, we were very fortunate to have as our subcommittee, if you will, leader at that time, Dagmar Atkins, who was very much active and is extremely knowledgeable about various aspects of inputs. So we started off with oil as a three-letter word, and I'll come around to that as to why. It's especially helpful in describing petroleum in everyday general public discussions, which is fine. It's a three-letter word. However, it's important to understand that petroleum, that is oil, is a complex mixture of hundreds to thousands of individual chemicals. Now, this is known to most people who are viewing this webinar. However, it's not known to very many other people, and we'll come around to what this creates in terms of some misunderstandings from my personal perspective. The chemical mixture differs for various types of inputs of oil to the sea and for each oil, sometimes markedly so. These differences allow for forensic analysis to distinguish one oil from another for determining the source of a specific oil spill, for example. These compositional differences are important considerations when responding to oil spills, and the regulation and control of various types of inputs. And each chemical has its own set of important characteristics, e.g. volatility, solubility in seawater, etc., that contribute to the fates and effect of complex mixtures once released to the environment. In a sense, we're talking about the thermodynamic properties of individual compounds and of mixtures of compounds. And we go into that in some detail in chapter 2. And I'm not going to go through that right now. One way to think about this and explaining it to the public is that each chemical has its own important characteristics. In a sense, it has its own personality. Each chemical has its own personality. And then it's in a group of people, if you will, in a crowd. And all of those individual personalities affect what the crowd is doing. We spent some time on that, and my personal comment is that intense debates in the late 1960s and early 1970s about fates and effects of oil spills happened in part because studies of 3 spills in particular contributed to the debate. Now, we all know that each spill can be in a different type of ecosystem. Sometimes they're in the same type of ecosystem, like the one in Buzzards Bay, where it had 2 in a row. Each spill that I'm describing here that contributed to this debate was a different type of oil. So in a very short period of time, 69, sorry, the Platform A Santa Barbara oil spill in the Santa Barbara Channel, crude oil. Later that year, on September 16th, the Barge, Florida, West Falmouth oil spill. In this case, number 2 fuel oil. And then in February 1970, the tanker Arrow in the Chattahoochee Bay, Canada, the bunker sea oil. Now, I've been involved in several of, or was involved in several of the debates at that time about fates and effects of the oil. And one of the things that one could take away from these debates is that making such comparisons, you have to take into account the chemical composition. Chemical composition matters. Okay. It's my personal comment and emphasis. Now, since oil in the C3, the analysis of oils, inputs, oil and samples from the field, laboratory and mesocosms have benefited and benefits from decades of experience in new analytical chemistry methodology. And we go through some of that in the report in some detail. I'm not going to do that now. I'm just going to use figure 2.1 from oil in the sea. You can see the flow diagram. Before we get into aspects of that, please note at the bottom left the note. Not all newer and potentially useful instrumental analysis are shown. And this is particularly relevant to the various things shown at the bottom of the flow diagram. We basically have chromatographic separations into the SARA, the saturates, aromatics, resins, and asphaltenes. And then from there, we go on to various instrumental techniques. I'm going to only emphasize a few things from this slide. The details are in the report. So, first example, 2-dimensional gas chromatography, or GCGC, developed by Lee and Phillips in 1991. All of the references that I'm mentioning here are referenced in the report. From that, there were a number of people involved, but particularly significant advances in GCMS applications to analysis of petroleum, hydrocarbons, and oil spills by Freisinger et al., Freisinger and Gaines, Gaines et al., Freisinger and Gaines. All of this centered at the U.S. Coast Guard Academy, in the faculty and research groups there. They then interacted with Chris Reddy and Bob Nelson and others at Woodsville Oceanographic Institution. This is only one of their interactions. And they brought GCMS to analysis of a wide range of petroleum hydrocarbons and sediments and other samples. And you can see all the references to this in Oil in the Sea 4. On the bottom, on the right-hand side, I draw your attention to another significant advance. Ultra-high resolution mass spectrometry, such as that is available in the high magnetic field Fourier transform ion cycling resonance mass spectrometry at the National High Magnetic Field Lab at Florida State University. This allows hundreds to thousands of compound elemental formulas to be identified. It's important and valuable information to know, for example, that a particular fraction isolated from tar that is weathering on a beach has added more oxygen compounds, a significant number of oxygen compounds as a result, for example, of photooxidation. The challenge that we now face is to unravel by other analyses, other analytical methods, the molecular formula of the key individual or groups of these compounds. That is, what's the molecular structure of this? And that's going to take a lot of work. But the ultra-high resolution mass spec has contributed significantly to what we understand, particularly about weathering. And the final example is in situ analytical systems for use in the field during and after a spill. Remotely operated vehicles, autonomous underwater vehicles with an evolving suite of detectors, cameras, UV fluorescence, mass spectrometers. When I first started out as a postdoc in Max Bloomer's lab in 1971, if I had mentioned to him we wanted to take a mass spectrometer and put it in seawater, he would have been aghast. That just gives you a sense of the tremendous advance that we've made since that time. One of these mass specs, my colleague at Woods Hole, Rich Camilli, has developed underwater mass spectrometer system, and that was actually used on one of the AUVs during the Deepwater Horizons. Well, to take a look at the submerged plume. So summarizing chapter 2, we went through definitions and classifications for the chapter. I haven't gone into all of this, I'm just telling you what's in there. We talk about chemical composition, sampling and analysis, in situ measurements and chemical analysis, the thermodynamics of the oil mixtures and the phases and states of the oil in the sea. And let me point out that these last two in particular, but chemical compositions as well, provide a significant background to one of the points that we make in the conclusions and recommendations, modeling. So conclusions and recommendations talk about the summations in analytical chemistry methodology, the challenges that this has brought forward in reporting of chemical compositions, which is resulting in large databases, and the challenges of curating and accessing or entering, curating and accessing large databases, making them generally available, and how this influences modeling, which will come up in later chapters in response and in fates. And finally, we also point out that there are new fuels coming online. Low sulfur fuels are being used in ships. We have biofuels and so forth. Even though the terminology is a biofuel, we shouldn't automatically think that there's not going to be any problems with the biofuels, because they're admixed many times with existing petroleum fuels. So we talk about the necessity of keeping our eye on what are the compositions of the new fuels and what are their thermodynamic properties and phases of states. So here's a personal quote. personal emphasis. The oil is a three-letter word that's helpful in describing petroleum in everyday general public discussions. From this, and I found throughout my career, we need to educate many of the non-scientist engineers. There's a significant difference between the chemical composition of vegetable oils, animal fats and grease, suntan oils, and the chemical composition of petroleum. I particularly put suntan oils in there because in the mid-1970s, I was aghast to read in one of the national newspapers an advertisement put there by one of the major oil companies that was trying to lead the public to the situation where a person with suntan oil diving into a pool, that is a person who would put on suntan oil, diving into a pool, was adding more oil pollution to the pool than was generally being added to the ocean. I contacted one of my colleagues at one of the major oil companies and said, don't the advertising people understand the composition of oil? And there was a little bit of a kerfuffle about that. Let's now turn to inputs. And here is a diagram, cartoon over, not really a cartoon, a very nice drawing about the various inputs. I will note that for some reason on this particular slide, when I uploaded it, the atmospheric deposition became ferric deposition up at the top there, and I apologize for that. But these are the various types of inputs that we talked about in detail in the report in terms of chapter 3. And we'll come through some conclusions on almost all of these. Now, this is a very busy diagram, and I encourage you to get into the report to understand more about what this all means. But what it is showing is an average between 2010 and 2019, an annualized average of oil inputs to the sea for these various locations. It's very hard to see these, at least for me, to see these letters around the coast. Natural seeps are indicated in yellow. Land-based inputs, that is runoff, sewage, that sort of thing, is indicated in green. Operational discharges are indicated in the purple, and then accidental spill inputs in red. Now, if you look down in the Gulf of Mexico, obviously you'll see that the accidental spill input is 57,000 metric tons. That includes the Deepwater Horizon. At the same time, land runoff over that period of time, annualized over that period of time, is 59,000 metric tons. I'm sorry, natural seeps, 59,000 metric tons. Make that correction, natural seeps. And land runoff is estimated at 230,000 metric tons. Now, in the report, we go into great detail pointing out how there's large uncertainties associated with some of these. And I'll go through some of this as we go forward. You'll notice that it depends on the region of North America in terms of these various types of generalized input categories. So compare the Gulf of Mexico, for example, to the Northeast Megapolis running from Chesapeake Bay, sort of Washington, D.C. area, if you will, up past Boston, and you'll see that land runoff is the most significant input in comparison to all the others. In a table, if you compare oil in the C3 with oil in the C4, annualized metric tons per year inputs over the 1990 to 1999 for oil in the C3 on the right-hand side, oil in the C4 on the left-hand side. You see the natural seep estimates are somewhat down. That's what the blue arrows are indicating. Extraction, which includes spills from the Deepwater Horizon, 67,000 metric tons per year. Excluding the Deepwater Horizon, about 10,000. Our very best estimates that we can come up with indicate that the inputs from extraction have gone up a little bit. For transportation, you make a comparison, we think there's been significant improvement in terms of curtailing oil input to sea from transportation problems. On the other hand, from the next category of consumption, we believe that there's been significantly more input. However, and we go through all the reasoning behind this, these are estimates with large uncertainty. We wish that wasn't the case, and I'll explain one of the challenges we face. And at the bottom, you can look at the significant figures, two significant figures, and what the various totals are, excluding consumption, and then excluding consumption in the Deepwater Horizon. So in agreement with the 1975 report, Petroleum and the Marine Environment, the first of 4 in the series, I quote, "There is a significant lack of systematic data collection concerning petroleum hydrocarbon discharges in the ocean." By the time of the Oil in the Sea 3, there's a quotation in the report. Lacking significant data was based on estimates of, and in some instances, educated guesses, end quote. And in Oil in the Sea 4, the latest one, there are, quote, more specific data on some inputs, like spill volumes, permitted discharges, other values and input categories. But the other values and input categories remain vague. For example, land-based runoff, sewage discharges, 2-cycle engine inputs, atmospheric deposition, and emergency dumping from aircraft. And these values are either vague or non-existent. For natural seeps, we've had progress in identifying seep locations, but not much work has advanced quantification of oil and gaseous seeps, particularly outside the Gulf of Mexico in areas such as the North Pacific margin and North American Arctic margin. Now, let me just make a point here. There have been some really very good studies about quantification of oil and gaseous seeps. However, there are not a large number of them, and they haven't been applied widely. So we need a better understanding, and this can be achieved through use of existing techniques, the published techniques of the last 10 years, let's say, along with exploration of new technologies for identification and quantitation or quantification of natural seeps. For operational discharges, this is the first slide. Exploration and production operations are permitted as long as they do not exceed maximum weighted average concentrations. Therefore, we don't know the exact concentrations. We just know that they're not above a certain level. And it's not reported, and it prevents an accurate estimation. We do know that regulatory changes have had a positive impact on decreasing operational discharges from exploration, production, and transportation. And these discharges are very small relative to potential spill volumes. Illegal discharges still occur. The best prevention is rigorous and effective enforcement, and there are technologies available, drones, satellites, et cetera, to use to improve surveillance and enforcement. And lastly, an important point that the committee made, corporate culture increasing the standard of care for environmental stewardship within industry has grown and continues to aid in reduction of illegal activities. Going to illegal discharges from ships, we don't know the extent of non-compliance. Inefficient 2-stroke engines. Federal agencies were asked from the Oil in the Sea 3 report, a recommendation, especially US EPA, should continue efforts to regulate and encourage the phase out of the inefficient two-stroke engines, outboard motorboat engines, and a coordinated enforcement policy should be established. Our committee, Oil and the Sea 4, commends the US EPA's efforts to address this important recommendation, and we encourage continued efforts to reduce the use of two-stroke engines in North American waters. On the operational discharges, let me just summarize this rather than reading it. Fuel dumped by aircraft. We just don't have that information, whether it's commercial or military aircraft. And we have a recommendation that this is an important gap and it needs to be filled. For accidental spills, we've already talked about excluding the Deepwater Horizon, spillage in US and Canadian waters from oil extraction activities is nearly the same as that estimated in Oil and the Sea 3. The shift away from coastal and nearshore spillage to more offshore spillage reflects the shift to deeper waters in both the US and Canada. We do have a significant amount of information and a call out section on the Deepwater Horizon. We know it's an unprecedented in volume. It's an outlier in 2010, 2019. It doesn't mean it's not important. There were extensive investigations post Deepwater Horizon by government agencies, industry, and regulators to prevent such a disaster from happening again. The term disaster is appropriate. Let's keep in mind, always keep in mind, that 11 people lost their lives. Continued support of technological and organizational improvements is critical to prevent large releases and blowouts in the future. For pipelines, government agencies and industries have improved pipeline systems as well as spill prevention. There are a lot of early detection techniques, and there's been a decrease in spillage, not spoilage, sorry about that typo, from onshore and offshore pipelines, despite the increase in pipeline mileage and barrels delivered. The potential for future spillage related to offshore structures, pipelines, and coastal facilities, particularly in light of increased intensity and frequency of severe storms and hurricanes related to climate change, represent a considerable risk of future oil inputs to the marine environment. And think about the destruction of coastal facilities during Hurricane Katrina, and think about the situation with respect to Mississippi Canyon Site 20 in terms of the mudslide caused by another hurricane that wiped out and buried a particular production facility structure. These are addressed in the report. For tankers and other vessels, double hulls on tankers and fuel tanks of other vessels help reduce the likelihood of spillage, especially with grounding. However, there's a concern with port congestion combined with the increased vessel size, making maneuvering more challenging. There are robust systems for monitoring and tracking that would decrease the risk of pollution incidents. Going next, aging infrastructure, abandoned wells and pipelines. These pose a potential source of oil input to the marine environment, and we suggest or recommend that appropriate federal, state, and tribal entities should take inventory of those not yet identified, triage all of them for potential losses, and as appropriate, salvage or cap these aging infrastructures. You just can't leave them there and hope for the best. We also know that there's an increased potential for future spills from shipwrecks from World War II. Many shipwrecks are located and identified. We have a figure in the report of this around the North American continent. There are quite a few. The U.S. Coast Guard and environmental authorities for the United States, Canada, and Mexico are encouraged to take advantage of existing data to prioritize RECs for monitoring, surveying, and potential oil removal operations. And speaking of the monitoring, surveying, and potential oil removal operation, new technologies are available for all of this to reduce the threat. Let's go to the last one, land-based sources. Oil in the Sea Theory recommended that we needed to have a systematic assessment of land-based sources of oil input. For example, sewage inputs directly at coastal waters and estuaries, land-based runoff. This recommendation remains to be addressed, and the recommendation is reinforced in Oil in the Sea 4 report. An oil slick on the street. Many people, when they think about oil in the marine environment, think about oil spills. This is what shows up in the media. Here's a picture of an oil spill. Credit Alan Mearns, our colleague, as per the 2022 Oil in the Sea report. I've explained this issue throughout my career because in my dissertation research in Narragansett Bay, I stumbled upon something which in hindsight, obviously, was obvious, and that was that there was a lot of oil coming down the storm sewers in Providence, Rhode Island, entering upper Narragansett Bay. And so throughout my career, I've been trying to explain all of this to the public, and I found that the following cartoon, which is an original by me, is very helpful. We have the dribble, dribble, dribble of crankcase oil mixing in, we should put in now, the asphalt on the roads, the exhaust coming out with the aromatic hydrocarbons from combustion processes mixed in with some other petroleum. And particularly, I'd like to note, and this goes over really well with younger audiences, that the car has a downturned mouth. It's not very happy with what's going on here. My personal emphasis on this is that people need to understand that there's a difference between the chemical composition of vegetable oils, animal fats and grease, suntan oils, and the chemical composition of petroleum oils. Making total oil and grease measurements in sewage effluents is a good start in land runoff, but they're insufficient. There's a need for measurement of fossil fuel hydrocarbons and combustion product hydrocarbons in many more locations. There have been a few studies, and we cite those in the Oil in the Sea 4 report, that clearly point out how this can be done. There are updated methods of measurements of oil and grease to move beyond total lipids and assess petroleum oils, as indicated here. Modern analytical chemistry methods have automation features that ease the burden for these measurements. Why should we do it? Because all of these provide a moving baseline of petroleum hydrocarbons and combustion products, pHs, et cetera, and inputs to coastal areas, which are also susceptible to accidental spills. We need to be worried about the synergistic and antagonistic actions on the accidental spill inputs from both a fate and effects perspective. And also we need to understand that that's a baseline, maybe a moving baseline, but it's a baseline against which we need to take a look at the accidental spill inputs. So summarizing, I'll bring you back to this. In this report, and I encourage you to read it, there is much more detail than I've been able to present here. There's much more information, important details. I encourage you to take a look at it. I realize that it's a 450 plus page report, but it is loaded with information backed up by several thousand references to the literature. Thank you. to ExxonMobil, especially Tim Nedwood, for the invitation, to the Oil in the Sea 4 Committee to present aspects of Oil in the Sea 4, and to Lynn for hosting and for valuable assistance. And thank you to those of you who logged in for this live webinar or the recording of the webinar. And I'm open to questions or comments. Thank you very much.
Thank you, John. That's great. Yeah, that's wow. I learned a lot from your presentation, and so it seems we have a couple of questions or comments coming in. Let's go through this first, and while we're waiting for others to input your question, their questions as well. So one question is about GCGC analysis. Could you comment on recommending a standard format for reporting higher resolution analytical data, such as GCGC data that links to oil spill fate models?
Okay, let me think about that. So they want a standard?
Yeah, standard. Yeah, recommending a standard format for reporting higher resolution analytical data for oil spill models.
Let me think about it. It's a very good question to start with. I'm probably not the best person to do that. We do recommend that in the report. There is a report on intercomparison, intercalibration exercise that took place during the Deepwater Horizon. That was funded in part by the Gulf of Mexico, or almost entirely by the Gulf of Mexico Research Initiative. There were, I think, at least 2 laboratories. One was the laboratory of Chris Reddy at Woods Hole Oceanographic Institution, Chris and Bob Nelson. And the other was at the National Academies, not the National Academies, I'm sorry, National Institute of Standards and Technology. And both made measurements. And there is a report from the National Institute of Standards and Technology on this that I believe contains some information for that. But the answer to the question is, I don't know of any recommended format right now. What we recommended in the report is that this needs to be addressed. And I'm sorry that I can't go, I can't provide any more of an answer than that. I hope it's helpful.
Okay. And another is a comment, just a note that the increase of input in exploration volume category is not because of the spills, but due to the increased volumes of produced water corresponding to higher oil production volumes.
I stand corrected.
Yeah. I think in your presentation, like following on the exploration volume, you did mention the spills as well. So another question is, one of the items that came up often is related to recommendations. What entity should carry them out? How do we, like the public regulator, prioritize these recommendations?
Yes, we had a great deal of discussion about that in the committee, and I think that Kirsty Tika addressed that to some extent in her presentation in the previous webinar in this Oil in the Sea 4 series in terms of her overview. There is my older mind is going to lose the exact title, but there is an interagency group at the federal level that is coordinating various aspects with the different agencies. But this is a real problem, and we discussed this a bit in the report. But the problem is you make a recommendation in 1985, and by the time that comes out 2 years later, at least in the United States, I'm not saying this is wrong, it's just a fact of life, that government is reorganized, and so the agencies involved are different agencies, they have different priorities, different funding, and so if you recommend that, for example, EPA should address this particular thing in 1985, by 1990, that may not be in their agency purview anymore. So this is a real challenge. And somehow there needs to be some coordination brought to this that is tied, not just to coordination, but is actually tied to funding. It's all fine and good to sit down and make recommendations. And at the end of the day, the issue is, where's the funding to carry out the recommendation? I know that's not an answer completely in terms of what entity, but that, quite frankly, is something that is not the responsibility of a National Academies committee per se. It is the responsibility of the different elected governments to come up with that sort of thing, which means that communicating these reports, one of the key issues in communicating these reports is to get them to the staff members, especially of the various elected constituencies within, let's say, the United States, Canadian, and Mexican governments. And there is progress being made, I think, and last I knew, on a more, quote, public user-friendly report that won't have all of the details. Now, there are summary sections in our report that provide what I think are some significant, interesting recommendations that are in language that I believe is relatively easily understood by elected officials and their staff. But as we all know, there are a number of large competing priorities. That's the answer that I can give. It's probably not satisfactory, but it's the best I can do.
Yeah. Another question is, through your over 50 years attending, observing, analyzing, researching oil spills, could you highlight any personal observations on notable changes observed?
Yes. I indicated that with the the late 1960s, early 1970s, oil spills, there was a great deal of discussion and argument back and forth because people were studying these spills in the field, and in fact, they were taking those particular oil or samples of those spilled oil and doing what I didn't mention. They were doing various experiments in the laboratory and talking about biological effects, for example, and talking about things like fates of oil, and even arguments about how to analyze these oils. It just happens, and I'm not saying this because this is an ExxonMobil webinar, but it turned out that Exxon in 1974, invited a number of us to come to a workshop to discuss aspects of oil spills in the marine environment. And one of the recommendations from that workshop was a published public report, was that there should be a series of standard oils available for people who wanted to test out new analytical methods and compare their data from one lab to the next, as well as to understand experiments that were relevant to effects and fates. And that recommendation was taken up by API, the American Petroleum Institute, and they collected and made available 4 oils of different types. And I think that made a significant advance, at least in trying to reduce the complications and confusion and comparing various fates and effects experiments, for example, in the lab. So that's one observation. The second one I indicated was that the NOAA and Coast Guard oil spill response that I observed being at sea and being involved. In fact, we had some NOAA people on a cruise with us on the research vessel Oceanus in December to the Arbor Merchant. They were tremendously dedicated individuals, very well informed, working hard. And that is carried out throughout what I've seen at various spill locations. Sometimes in the pressure of the moment to do something, do anything, some mistakes have been made. I mean, they started with, such mistakes started with the Torrey Canyon, for example, where they tried to use napalm to light the oil on fire. They continued, for example, and I'm not criticizing the people who made a decision because they were under pressure to do something from government agencies. Certainly hot water washing, the EVOS spill on some of the rocky intertidal areas was not the best approach to be used, and we know that now. We learned from that experiment. The other thing I've noticed is that the general knowledge has grown significantly. There's much more interaction and discussions that take place. Maybe there are debates and arguments at times, as I've indicated before, between various people in different sectors. But there are places where these people can come together at meetings, and there's much more of a community writ large to address various aspects of inputs, fates, and effects. I'll leave it at that.
Thanks. So, so you have a unique situation. You basically involved all 4 oil in the sea series, right? So, just wondering, I know you're talking about inputs, but overall, what do you think the important aspect of the the latest version, the oil in the sea 4?
Oh, I think the latest version of the oil in the sea 4, and I just can speak for myself, I can't speak for my colleagues on the committee. It's a tremendously informative report. It's absolutely amazing how much information and new knowledge we've gained. My personal concern is that this was driven in large measure, but not completely. This was driven in large measure by the Deepwater Horizon, but it was also informed by various different spills, and these were outlined in some areas of the report, and we used examples of various different types of spills with different types of oils. And the advance in knowledge is significant. The one observation I have is that Deepwater Horizon was a while ago. Are we going to continue to make progress? Is there going to continue to be funding, or is it going to sort of fall off the table in a sense because it's not the latest thing in the news cycle? That's a reality of modern society, but I think we need to keep pushing hard to at least have a continuing fundamental base in government agencies, funding in the academic sector, as well as in the oil and gas industry. And I think in one of our public, well, I shouldn't say that. I would say that one of the things that we've identified, and it's something that a lot of people don't think about, is the fact that severe storms seem to be becoming much more frequent. And they're interacting with an aging infrastructure. Who's responsible for that? Keeping track of that? Who's responsible for preventing oil spills? Or is anybody just going to say, my personal comment, for example, my personal comment, well, the storms are much more significant and we have many more important things to deal with during that, so we'll just let the oil spill. So it's a rhetorical question, but it's a comment.
Yeah. That's a hard one.
Oh, it is a hard one. I've testified before Congress many times and talked with congressional staff members, and it's exceedingly difficult to for the general public necessarily to understand all of the different requests that come to the United States Congress, and I assume this is the same in Canada, to their parliament and to the Mexican government. There's all sorts of different requests for funding, and we need to deal with this in priorities. And these funding requirements and requests for regulations and regulation updates, again, this is my personal comment, are things that there's just no way that all of them can be done with the existing funding or the existing time that these legislative bodies have available to them. So we need priorities. I remember testifying before a Senate subcommittee and having the late Senator Lowell Weicker, who was the chair of the committee, ask me, I don't understand. This was right after the Beach Dock 1 spill. And I was very tired and I was there to testify along with other people. Just come back from the cruise, and he said, I don't understand, Dr. Farrington. I've had my staff look, and there are, a number of grants or amount of funding that goes to different federal agencies to deal with oil spills and that sort of thing. And yet you're telling me we don't know a lot of these things. And my answer was, Senator, with all due respect, the rate at which Congress asks questions of the scientific community is out of proportion to the rate at which it provides the funds. Several of my colleagues who were sitting next to me at that time moved their chairs away because they thought I was going to be hit by a lightning bolt. But Senator Leiker said, oh, sir, I'm on your side. So, but I guess the lesson from that is don't testify before a Senate subcommittee if you're very tired.
All right, so it seems we don't have we have one more question to type in. Which 3 inputs should be prioritized for research? With the 3 inputs that have the most gaps in knowledge and research?
Well, certainly, my personal opinion, and I think that comes through in the report, is that land-based inputs has the biggest gap. I would say after that, whoops, my local phone, I apologize for that. My wife is getting it. I would say, after inputs or equal to inputs would be understanding something that could be relatively easily reported would be the dumping of fuel by aircraft, the various types. And some people say, well, what's the problem with that? Well, a lot of times the dumping of the fuel for coastal airports anyway, major airports, for example, in the United States, is done, quote unquote, safely offshore in the coastal area. Only once in a while is the emergency such that the aircraft have to dump the fuel over the land areas of the coast, and especially urban areas. And when they do that, it gets in the news. So that's two. Let me think about the third. While I'm thinking about that, well, I'm not going to give a third. I think you can read the report and figure out on your own what you think should be prioritized.
Okay.
I don't think that we didn't prioritize things. We made recommendations and conclusions. And I will say that I have managed to see one of the comments online now, and I thank Ed Levine very much for pointing out that what I was referring to is ICOPAR in terms of the interagency group in the United States that has responsibilities for bringing together the various agencies. But my understanding is that ICOPAR actually doesn't have a large say about funding per se.
Mm-hmm. Okay.
Perhaps that could come up during the discussions later in the series when Ed Levine leads the, I think we're going to have a panel presentation.
Yep. Yeah. At the end.
So that would be a topic for that.
Yeah. In December, we're going to have a summary and recommendation led by Ed Levine. Oh yeah, before everybody goes, that so our next month webinar will be the response, and the speaker is Victoria Brogy. So stay tuned. Yeah. So yeah, it seems we are out of questions, and thank you so much, John. And I know, it needs quite effort to put all the slides together and give a talk. And thank you so much. We really appreciate.
Thank you for the invitation, and thank you for the questions and comments.
Thank you. Thank you, everyone. Thank you, John. Bye-bye.
All right.